Hi, I'm Francesco Vasali. I am a AI engineer at Jippity. We are a startup that does quite a lot of RAG actually. We generate code for students learning JavaScript. I have never used GraphRAG before, so I thought this was a great opportunity to try that out. So I'm going to present my submission for the ArangoDB Agentic GraphRAG Hackathon. So for my data set, I went to the Sudanese Civil War Wikipedia page, but instead of using the Wikipedia page itself, I went to all the sources in the intro section and copy and pasted the article text for those sources into my agent basically. So the core of my agent is a tool calling system using GPT 4.0. Since creating the knowledge graph wasn't meant to be the focus of this hackathon, I'm not going to go into too much detail on that, but you can see here the system prompt I'm using to tell 4.0, here's a piece of text, extract out all of the named entities from this text, and those are going to become the nodes of our graph. The second step is then finding relationships between those nodes. And I use a separate system prompt for that in a series of tool calls, basically, to go through and make sure that we're not dropping too many of these. And this is very similar to the process described in the Microsoft blog post in the accompanying paper. So once we've loaded all the sources in using that expand knowledge graph endpoint, we're going to convert that graph into the network X format and attach the ArangoDB backend and persist that in the cloud. So that's all pretty clearly explained in their documentation. Now if we look at the graph at ArangoDB, we're going to basically see the beginnings of the problems with a simple agentic graph creator, which is that this graph is way too sparse. There's too many nodes that have no connections at all. But we're going to double down on the agentic system to see how we can resolve that. We're going to load up the ArangoDB LangChain community package, which supports natural language querying of the graph that we now have in the ArangoDB cloud instance. And with this algorithm, we're going to find nodes that are part of that sparse part of the graph and then see which of their summary words match with other nodes in the graph and ask the ArangoDB QA chain to submit a query for adding a edge between those two nodes. So here's what the graph looks like after automatically finding all those connections. It's much denser, which this is going to be good because the Microsoft paper says in the next step, but before we get to RAG, we still need to generate communities and community summaries. And basically communities on a graph are areas of neighbors that are more connected to each other. And this is where cuGraph is going to come in. They have the Luvian algorithm, which is a community finding algorithm. So I can take the ArangoDB backend plugin for the Network X and just directly call the Network X Luvian algorithm to get that cuGraph implementation. Have the communities identified from the Luvian algorithm. We're going to generate community summaries, and here's the system prompt for doing that. And this is going to be useful in the final step of doing the GraphRAG. So now that we have the community summaries, we can actually get into the fun part, doing GraphRAG. And the heuristic is going to be that the user asks some plain text question that gets sent to all communities to generate community summary, and then the community summaries are summarized into a global answer. But that's just basic GraphRAG as defined by or as implemented by Microsoft. With ArangoDB and cuGraph, we can implement a hybrid query model where on top of that system, we're also going to query the graph with some simpler heuristics like which of the entities in the question and answer are mentioned in the graph, grab them, grab their neighbors, and then take that subgraph and apply the cuGraph PageRank algorithm and see, okay, what are the influential members here? So we can add this dual context to what the user is asking for. So let's look at a couple examples.
Quick piece of background of what you're looking at here. This is a fast API. So your browser can just run pieces of the Python backend, and the Python backend is running as a Docker container mounted onto my local network.
Okay, first up, I know from just reading a little bit that this is a very fluid war with many different sides. So I'm going to start by asking for an answer on which groups have switched allegiances during the Sudanese Civil War. And after running for a moment, it'll give me this response. I'll just copy and paste this into a Word doc to make this slightly easier to read. And what we see with this answer is that it's pretty concise. Talks about the two main groups and some people that started off as neutral and then aligned with the Sudan Armed Forces. And I want to draw your attention to the bottom of this where we're adding in these results from our hybrid query and say, okay, we're using PageRank, and this predicts that this Sudan Armed Forces SAF is the most influential entity among these. Obviously, they could clean up the name and that sort of thing to make a nicer UI, but that's the gist of the hybrid query. And the agent is going to be smart about using these. It's not going to do them when it's not like a reasonable result. For example, one of the demons of RAG is getting the machine to admit when it doesn't know something. So here I asked a question that it probably could know if it went and searched the internet, but wasn't included in the articles I gave it, which is, what is the role of oil in the Sudanese Civil War? And we see that it says, okay, well, these recent news articles that I have access to don't explain the role of oil specifically in the Sudanese Civil War. And so that it doesn't try to do some sort of page rank for something like that. We can also compare our concise answer about shifting allegiances to what GPT would say if it wasn't doing RAG at all. So I just went to the GPT playground to see what the response would be, and you see that it doesn't even start to address actually the current civil war until the fourth bullet point here. So we're really shifting what the model is paying attention to by giving all of these documents. And I tried doing this with just ChatGPT as well, and it actually decides to search the internet, and then it found even some of the same articles I used to make the documents. So that one gave a very similar answer. So overall, building a agentic GraphRAG system was a fun challenge. I'm glad I got this working, and looking forward to what else I see people doing with it. So enjoy.